There are three main components to the Picture Perfect Science program. The first one is scientific inquiry. All of our lessons are based around a science concept. The second is the 5 E's model. They are all formatted according to the phases of the 5 E's. And the third is picture books.
There are so many things and so many of the standards that are met through a lot of the lessons that Karen and Emily have created for us.
I think one of the really great things about the Picture Perfect lessons is the 5E model, really getting the kids to engage with the picture books before you even start the lesson.
The books in the series are Picture Perfect Science Lessons, more Picture Perfect Science Lessons, and our new book is Teaching Science Through Trade Books, which we co-wrote with Christine Royce.
The students really enjoy the lessons, so it's able to give them joy, and I enjoy teaching.
Well, there's a lot of reasons to use picture books to teach science, and the biggest one is really the lack of time. It's really hard to fit all of the subjects that we need to teach into the school day. So by integrating subjects, we can get more in. One of our big goals with Picture Perfect Science is to get more science in the elementary school day. And so we believe that combining that with reading will accomplish that goal. Another reason to use picture books to teach science is it gives kids a context for the concepts that they're learning. A lot of the concepts that we teach in science are abstract, or maybe they're just not very meaningful to kids. So a good picture book can really help them have a context. For example, the book Somewhere in the World Right Now by Stacy Schuett is really good for giving kids a context about the Earth's rotation and day and night. So I'll just read a few pages of it to give you an idea of what I mean. Somewhere in the world right now, it's deepest night. We ask the kids, is that true? That somewhere right now it's night? How can that be? Fog hugs the shoulders of buildings and bridges. A baker slides long loaves of bread into an oven. Somewhere somebody watches a movie. A mouse hunts for crumbs. Somewhere else in velvety darkness, elephants sleep standing up, swaying gently from side to side. Whales breach and dive in the sea, singing their low, sweet songs. But somewhere else, right now, tomorrow is already here. Is that true? Somewhere right now it's already tomorrow? Dawn is breaking, a rooster crows, and people are waking up. So this book goes on and talks about all the different things that could be happening right now. And so the kids have that question after reading, how could all these different things be happening in the same moment? And we give them a lamp and a globe, and they use that to answer the questions. And we talk about how the sun is always rising somewhere and the sun is always setting somewhere. So it gives them a context for that concept of Earth's rotation causing day and night. Another reason to use children's picture books is just engagement. You know, we don't get to decide what we teach anymore. We all know we have our state standards and we know what we need to teach. So the art of teaching now is really getting the kids interested in what they're supposed to be learning. And picture books are great for that. For example, Roller Coaster by Marla Frazee is a great book to get kids engaged in a lesson on force and motion. And we use this in a lesson in more Picture Perfect Science lessons. And we ask the kids, you know, have you ever ridden a roller coaster? And if you haven't, what do you think it would be like? And we pair that with a book called I Fall Down, which is a nonfiction book which teaches the kids about gravity and falling objects. And we relate that back to the roller coaster, that the roller coaster is being powered by gravity. That gravity is pulling that roller coaster car down the track. And the kids do some hands-on modeling with some tubes and balls and make their own little model roller coasters. So through the use of these two books, the kids get engaged in the lesson and they get the information that they need to learn about force and motion.
I'd like to take you through that 5E's learning cycle model using a lesson from more Picture Perfect science lessons. It's Chapter 9. It's called Loco Beans. The first thing we do is give the students a mystery object. In this case, it's a Mexican jumping bean, which is actually the seed pod from the jumping bean bush containing a small larva. The students don't know that. They just think, most kids think, it's a bean or a seed. So they draw a picture of it, and then they write different observations about it. After a few minutes, the seed pods start to warm up, and the larvae inside start to wiggle around, and the kids get really, really excited. And they start to say, mine moved, and we say, oh no, that couldn't happen. And then the other kids say, oh no, mine moved, and they get so excited. So it's a perfect way to engage them and getting them to want to know what is going on with the mystery object. So as they're writing their observations, they're also writing their wonderings in the OWL chart. And throughout the lesson, they'll learn a lot about the mystery object, and they can record those in the third column of the OWL chart. So that's the engage phase. During the explore phase of the learning cycle, the students take more measurements, make more observations, add to their wonderings, and really it builds that excitement. They really want to know what is going on with the mystery object. Then they share their inferences. What do you think it is? What do you think is inside there? Is it living? Is it non-living? And so on. So we really give the kids a chance to explain what they think. The next phase is the explain phase. And for this one, for this particular lesson, we use a book called Lucas and His Loco Beans. But we don't show them the cover of the book. We just begin reading. And we tell the kids that this book has some clues as to the identity of their mystery objects. So they're listening very intently for those clues. I'll just read a little bit of it. Abuelo, abuelo, I yelled as I ran. I hugged him and held him, grabbed hold of his hand. Each verano, I visit Abuelo's small ranch. We fish and we swim when given a chance. Early one morning, we walked a long ways. Over rocks and through bushes, we trekked through the maze. So the grandfather explains that they're going to a place in the mountains where he played as a child. And he says, keep very still. Now, what do you hear? He pushed apart bushes and then pointed down. Many semillas were jumping around. Click, 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 snap, snap, snap. The soil looked alive, and I quickly stepped back. So the students see the illustration in the book, and they recognize that those are indeed the same things as they have at their seat. Are they alive? I asked, quite surprised. Yes, I'll tell you a story if you sit by my side. So the grandfather goes on to explain that when he was young, he had some of those in a box, and they were wiggling around. Inside was a larva, and the larvae were eating the inside of the seed. After several months, they'd go very still, and he would put the box on the windowsill and forget about them until one spring day when tiny moths would leave the seed and fly away. So the students learn a lot from this book. At the end of the book, there are some pictures of the life cycle of the Mexican jumping bean moth. They do an experiment to find out. First, they measure the room temperature, and they count the number of jumps that the jumping beans make at room temperature. Then they place the seed pods on a heating pad or under a hot light, and they count again the number of jumps that they make at that warmer temperature, and they compare. And finally, they compare to each other, and they actually find the median for the entire class. So there's a mathematics connection there. To evaluate what they learned in the lesson, we have the students do a poster about loco beans, and they have to include some facts they learned about them, a detailed labeled diagram of the jumping bean life cycle, a description of their investigation and the conclusion that their team came up with, and they can do an advertisement explaining what loco beans are and why they would make good pets, and for extra credit they can include some training tips for their pet beans. So if you want to do this lesson with your class, it's really important that every teacher in your school does it on the same day, because you don't want to give away the big surprise. The kids can take the jumping beans home with them, and some of them will actually hatch, and the moths will live just a few days. And that's one of my favorite lessons because the kids really get excited about it. And I think they learn a lot of good science and scientific inquiry.
Well, all of our lessons in Picture Perfect Science are inquiry-based. They're guided inquiry to where there's the student pages are included, the teacher notes are included, and it's very step-by-step laid out for the teacher to use. But it still is inquiry because it meets the 5 features of inquiry that the National Research Council has put out. The National Research Council says that if you're doing these 5 essential features of inquiry, you're doing inquiry. And those essential features are that the students are involved in a question, a scientifically oriented question, that they're collecting evidence to answer the question. That's the second feature. The third feature is that they create explanations based on evidence. The fourth feature is that they compare what they learn in their investigations to what is already known. And a lot of times that's where we pull in nonfiction. And the last feature of inquiry, the 5th one, is that students have a chance to communicate their findings. And that communication can be, just verbally. It could be a written assignment. It could be a poster session. There's lots of ways to do that. But if your students are doing those 5 things, according to the National Research Council, that you're doing inquiry. And all of our lessons include those 5 things, but they're in a very guided manner. At the end of every lesson, there's an inquiry place, which is a little box that has ideas for open inquiry. There's questions that students can investigate, and that would be an open situation where they have a question, or they could come up with their own question, and they would come up with how they're going to collect the evidence and how they're going to communicate and all of that on their own. We start with a book called That Magnetic Dog, and in this book we learn about Skitty, the dog here. Skitty has magnetic properties. She attracts food, and she also attracts people. And so this book just gets us thinking about what does magnetic mean? And it engages kids in the question, why do some things stick to a magnet and some things don't? And that is really our scientifically oriented question, our inquiry question that we are investigating in this lesson, is why do some things stick to a magnet and why do some things not stick? And that is that first feature of inquiry, that kids are engaged in that question. The second feature being that they're collecting evidence. So in order to collect evidence to answer that question, we have the kids test different items. We have several items that they predict which ones they think will stick to the magnet, and then they test it. And the kids are always surprised to find out that not everything that's metal sticks to the magnet. The next feature of inquiry is that they develop an explanation based on their evidence. So they look at the 2 piles of objects they have, of the things that stuck to a magnet, things that didn't stick to a magnet, and they come up with a hypothesis. Why did these things stick and these not? What's different? What's special about the items that stuck to the magnet? And we really just have them use the evidence from their investigation to come up with that explanation. So that's that third feature of inquiry. The fourth feature is where the kids compare what they have learned in their investigation to what is known in the scientific world. And that is a great place to bring in nonfiction. And so we use the book Magnetic and Non-Magnetic at this point for them to find out, why did some things stick and some other things didn't stick. And they learn from reading this book that not all metals are magnetic. They learn that the items that stick to a magnet are the items that contain iron. So that's a really important learning for the kids. The final part of this is the communicate, the time when the kids can communicate their explanations. And they create a poster and they label the items magnetic and non-magnetic, and they're able to explain why the items stuck to the magnet, that those items contain iron, and the items that didn't stick did not contain iron. So that's kind of an example of how we use picture books in inquiry. And we like to do a lot of fiction and nonfiction pairs, as you can see in this lesson. The fiction can get kids engaged in that question, and then they can get the information that they need from the nonfiction. This is a lesson from Picture Perfect Science. It's called The Changing Moon. And it starts with the book Rise the Moon by Eileen Spinelli, and the pictures are by Raul Colon. We use this to engage the kids in a lesson about the moon phases. It's a beautifully illustrated, poetic book, and it inspires some questions about the moon, like where does the moon's light really come from? And why does the moon look different times throughout the month? Does the moon really pull the ocean? So we just really use this beautiful book to get kids interested and engaged in learning about the moon. After this, the kids do a moon journal where they fill in some circles on how the moon looks throughout the month. And that's where they have an opportunity to really explore and to observe. So some of the questions from this book will be answered through their own observations. However, there's one question that can't be answered through their observations, and that's why does it happen? Why does the moon look different at different times throughout the month? And one part of this activity that's kind of fun is we send the kids home with a moon survey. And so they have to ask 3 different people, why does the moon look different times in the month? We answer that question through a modeling activity. And in that activity, we use a foam ball to represent the moon and a lamp to represent the sun, and the children's heads represent the earth. And they find out through that modeling activity that it's the moon's orbit around Earth that causes the moon phases. Depending on where the moon is in its orbit, we see different parts of the lighted side. So that is a real aha for the kids doing that activity. But there's still some questions that we have that were inspired by this book that we couldn't answer through observation, we couldn't answer through the modeling. So we use a nonfiction book called The Moon Book by Gail Gibbons. One of those questions in particular was about, does the moon really pull the ocean? And there's a section in this book about tides and how the moon's gravity really does affect the tides. After reading the nonfiction book, this is a kind of a unique lesson because we use 3 books. Normally we use 2, but in this lesson we use 3. We use a book called Papa, Please Get the Moon for Me by Eric Carle. And what the kids do with this book is they read the story, which is fiction, but they read it like a scientist, and they point out any inaccuracies, any parts that would need to be rewritten to be scientifically accurate. For example, the moon, it says, and indeed the moon got smaller and smaller and smaller. When the moon was just the right size, Papa took it. Down and down and down he climbed. And from the moon observations and the moon modeling, the kids know that the moon doesn't actually get smaller. They know the reason that the moon changes. So they have some fun with this book. They actually re-illustrate or retell the story with a little book that we have them make, and they tell it. They make it scientifically accurate with the correct moon phases. So that's really a higher level of thinking where you have to look at something and find the inaccuracies and then correct them. So we have a lot of fun with that, and we always tell the kids that, you know, this is a fiction book and anything can happen in fiction. So it's okay that Eric Carle, you know, made the moon get smaller. But it's kind of fun sometimes to look at it as a science person and correct those inaccuracies. So that's our moon lesson. At the end of the moon lesson, there is a quiz, a pencil paper quiz, where the kids are evaluated on whether or not they understand the reason for the moon phases and that regular pattern of the moon phases.